Now, chapter 2 and chapter 3 are closely related. So you master chapter 2 and chapter 3, you also master chapter 8. Okay? Right. Now let you have an overview first. What is differentiation? We will cover the concept of limit. Then we will go to the gradient of a tangent to a curve. And then from there, we will learn the differentiation by first principle. And then differentiation by first principle is very long. So we will go by the first derivative of various type of function, the shortcut of it. And then after you have done the first derivative, then we can continue to do the second derivative. So what is derivative? Derivative is another word for differentiation. And differentiation, D, remember, D stands for down. So it's the power, you down the power, you downgrade the power of the variable by 1, okay? You just remember that first. Now, so let's start off with the concept of differentiation. Why differentiation? Okay, where does it come from? Sorry. Okay. Wait, how come it lost the... I lost the hyperlink. Okay. Now, first of all, let's think about, let's look at concept of limit first, yeah? The concept of limit is written like this, yeah, this one. Okay, is the value of fx when x approaches the value of a. So, fx when x approaches a. So that is the limit. LIM limit, yeah? Okay, for example, if you are given a function fx equals to x plus 1, what is the value of fx as x approaches 0? You see, such a long sentence, the value of fx when x approaches a. So long. So maths people write like this. So this whole thing, how do you read? The value of fx as x approaches 0. It is not equals to 0. It is just x go as near as possible to 0. So in this case, this is a straight line graph. Do you know that x plus 1 is a straight line graph? It's a linear graph, yeah? It's a linear graph, passes through 1 on the y-axis. So y-intercept is 1. So if you look at the graph, okay, this is the graph. If we look at the table, using the table, yeah, and when x equals to 0, if you substitute x equals to 0, you get 1, no issue. But you take a value that is close to 0, but not 0. Let's say we take 0.0001, then you get 1.001. Okay, 0.01, a little bit further, 1.010. Then 0.1, even further, 1.1. Same thing goes to this, further to the left. Now, the idea of x approaches 0 means what? As your x go near to 0 from the right and from the left, so as the value of fx when x approaches 0 from the positive side means from the right. Okay, from the right. So from the right, you will notice that the line getting the y value from 2 to 1 point something, until you come to this point that is 1. If you go the other way round, okay, the value of fx as x approaches 0 from the left. Okay, when x go from the left, your y value along this line getting closer and closer to 0, closer to 1 also. So when you have your fx value as x approaches 0 from both sides, right and left, that is equal, then this function exists. Yeah? This is a continuous function. So limit exists. The limit exists because the limit from the right side and the left side, you will approach the same value of the y. so it exists. Are you okay? So by table, you will notice that all get closer and closer to 1, whether from the left or from the right. By the graph, you can see that as x going near and nearer to the 0, your graph, your y value all goes to 1. Okay? Right, so that's the idea of concept. Now, but why must we have that? Because sometimes you may not be able to get the value when you substitute like this one. Actually, you just need to substitute 0 inside, then you can find the answer. Then what's the big deal of finding the limit? Because some of the expression, when you substitute the value, you can't find the answer. For example, you may have something like this. When you substitute, right, you got 0 over 0. When you have 0 over 0, we know that it's impossible. Okay, no solution. No solution, because our denominator can never be 0. Okay, so when you have 0 over 0, okay, this is not equals to 0 over 0 when you substitute. So when it is not equal, then you can directly substitute in it, no issue. Okay, you want to find the fx value as x approaches a, you can just substitute the a directly into the function. But when you substitute directly, you notice that I got 0 over 0, you know. Okay, your level is only learn 0 over 0, yeah. You may have infinity over infinity. Now, infinity over infinity not necessarily is infinity, yeah. It could be 0 also. But you're not learning this lah, so let's forget about this. Okay, so FA, when you have this, what do? You must get rid of this element. Your objective is to get rid of this element. How? Either you do factorization, you factorize up and down so that the denominator can be simplified, or you use the rationalizing the denominator. So two ways, yeah. Okay, let's look at the example. Why must we learn this first? Later, yeah, we will come to the differentiation later. So let's look at the concept of limit first. Now you look at A, B, C, D. Right, D is the one that I add on. It's not in the syllabus. Whether it is in IGCSE, let me check first. I don't remember it is lah. Okay, the concept of limit. Wait, let me see. Concept of limit. Wait. Search first. You all don't have limit idea. 274. Wait, let me check first. The gradient function. You have the gradient. The gradient function. IG never learned the concept of limit. You're just okay. Right. Okay. All right. Fair enough, because you do not need to learn. You do not need to learn these two parts here. Limit you don't need to learn. First principle you don't need to learn. So these two taken out. You got extra exponential, trigonometric, and logarithm differentiation. That's all. So these two part, those who take IGCSE, you can just ignore, right? Okay. But for SPM, please pay attention. This one important. Now determine the limit value for the following function. So if you substitute 4 in it directly, we check the denominator first, because the most important thing is whenever you see x in the denominator, your x the denominator can never be 0, which means x plus 2 should never be 0. So x can be any number except negative 2. So now x approaches 4. That means I can just substitute directly, no issue. Unless x approaches 2, then cannot. So in this case, I can just substitute directly. So how do you write the value of 3 minus this? Okay, the value of the function as x approaches 4 is equivalent to the FA. So you straight away write FA in. So 3 minus square root of 4. So you are using the x equals to 4. So no need to write the notation limit. Okay, no need to write the limit x approaches 4 already. So 4 plus 2. So we will have 3 minus 2 over 6. So the answer is 1 over 6. Okay, fair enough. Right, next, this one. Now, the denominator shouldn't be 0. Therefore, your value of x cannot be 1. But over here, x approaches 1. Now, you see, if I substitute directly, of course, I cannot get the answer. But that is why the idea of limit is, you see, maths people are very crazy, yeah? Everything must have solution. No solution also, they have to think of a solution. How? I cannot substitute x equals to 1, right? Then okay lah, I find the nearest point possible. But I write x approaches 1. Okay, but not 1. But then how do I do? I can't just substitute any value like 1.1 or 0.999. It's so time consuming. So what we do is, we will do like this. Okay, x squared minus 1 over x minus 1 as x approaches 1 can be written as, now we're not substituting yet, so this limit notation must be written there. X squared minus 1 is actually difference between two perfect square, so we shall take the base x and 1, 1 plus and 1 minus. This is what when you have 0 over 0, there are two ways. One is you factorize, another one is you introduce the conjugate so that we can rationalize the denominator. So the x minus 1, the whole thing can be simplified. Okay? The whole bracket can be simplified. So what is left behind is x plus 1. So now you can safely put 1 into the x. So the answer is 2. Okay? So the idea of the graph will be something like this. You have x squared minus 1. Somehow, the graph x squared minus 1 is like this. No, it's not like this. The graph is like this. The graph, I don't know how does the graph look like. Okay, no idea. But when x equals to 1, right? It is 2 here. So it's a hole there. So the graph is not connected. It's not a smooth graph. It's not a function like in this case. Okay, because there is a gap in between. Sorry, it's not a continuous graph. Okay. Now what about this? If you substitute x equals to 0, definitely cannot, because the condition is when x can never be 0. Okay, whenever denominator contain x, you let the whole expression cannot be 0. So in this case, x cannot be 0. Then how can we do? I cannot factorize, impossible, but I can rationalize. Rationalizing always link with cert. When you see cert, right, you rationalize. Okay? So in this case, you have to introduce conjugate. So to introduce conjugate, you have to write like this. Okay, as x approaches 0, the function, okay, we write like this. This step must show you shall multiply with x plus 1 over x plus 1 plus 1. The two terms A minus B, then it will be A plus B. If the one given is A plus B, then the conjugate pair that you should introduce is A minus B. Understand? Opposite sign. So that we can achieve this A plus B and A minus B, it will be A squared minus B squared. This is actually the Form 2, Chapter 2, difference between two perfect square. Difference between two perfect squares. So now we haven't substitute, so we just copy the limit notation. Then over here we shall have x plus 1 square minus 1 square. What about the bottom part? Well, just put like this lah. Okay, so we will have, open up the bracket, so we have x plus 1 and then minus 1 over x square root of x plus 1 and then plus 1. Can you see that x plus 1 minus 1 is actually x, and the x can be simplified with the x at the bottom part, isn't it? X over x square root of x plus 1 plus 1. So simplify this, then we substitute. Okay, now we can substitute. So it will be 1 over 0 plus 1 square root and then plus 1. Yeah, no space, so you should continue here, half. Because 0 plus 1 is 1. Square root of 1 is 1. So 1 plus 1 is 2. So 1 over 2. That's the answer. Are you okay? So IGCSE, this topic no need to learn. Okay, this is just for knowledge. Alright? Your exam won't ask. But the idea of limit, this is the idea. Okay? Later it will further explain the idea of limit. So you must know lah. Okay? Try to understand that. Now, D, both IG and SPM, they don't ask this. Probably when you go your foundation, they will ask, okay? Now, this is when you have infinity. When you have infinity over infinity, can be solved. But we will take the concept of 1 over infinity equals to 0. This is the concept that we are applying. For example, okay, 1 over 10 is 0.1. 1 over 100 is 0.01. 1 over 1000 is 0.001. So as your denominator increasing, 1 over n, such that n approaches infinity, okay, should be like this. As the n approaches infinity, 1 over n will give us 0, because 0.000000000, so the number at the back is not significant, so it's almost near to 0. So we're using this idea to solve this. Now, how do we solve this? Yeah, so this one is out of your syllabus, but I think worth learning. Okay, can I erase all this? I erase all this first. So the D part, so as our n approaches infinity, so we have n plus 3 and n plus 4. Now I cannot cancel the n and n, I cannot. You want to cancel the fraction, it has to be one whole package. Because denominator, there is an invisible bracket for denominator, invisible bracket for numerator. You cannot just separate them yourself. You want to cancel off, you should cancel off the whole thing. But then how? So we want to apply the 1 over n concept. So what do? So up there we multiply with 1 over n, and at the bottom we also multiply with 1 over n. So for third form we multiply the conjugate up and down, and for the infinity we shall multiply with 1 over n. So when you multiply this into n plus 3, you will have this as n approaches infinity. So you will have n times with 1 over n is 1 plus 3 over n over 1 plus 4 over n. So now if you put the infinity in, isn't it you have 1 plus 0 over 1 plus 0, and therefore the answer is 1. Okay? Not because infinity divided by infinity equals to 1. No. You don't even know what is infinity. The infinity up there and the infinity down there may not be the same number. Okay? So you can't find the answer. Too large already. So we use this concept. Right? As long as you are able to write 1 over n, 1 over infinity is almost 0. So 1 plus 0 over 1 plus 0. This one is actually, I mentioned before, in geometric progression. Do you remember? Geometric progression, sum to infinity equals to a over 1 minus r. Why? Because your r is in between -1 and 1. So we shall use the formula of 1 minus r to the power of n over 1 minus r. Since r is in between -1 and 1, so definitely it will be written in fraction form, a over b. Okay, so when this whole thing raised up to the power of n, now this a and b, right, a must be smaller than b. A must be smaller than b. So if you were to put the power n in, this one should grow very fast. The b will grow extremely fast, so it would achieve infinity first. Therefore you have something over infinity, and therefore this whole thing becomes 0. That's how you derive 1 minus r. Okay, we actually learned this before. So are you alright? Can okay, for knowledge only, this one you don't know also, never mind. Right, then let's move on. Okay, so no solution here. Sorry, it's not that here no solution. Here no solution. When is equal, that is then no solution. When it is not equal, 0 over 0, then you substitute. Okay? Okay? Alright, now this is the idea of the concept of limit. Okay? Now the diagram shows fx equals to x to the power 4 minus x squared over x squared. Now your x can never be 0. So based on the diagram, okay, we need to find f0. Now x can never be 0 already. So what is f0? F0 is no solution. No solution. Understand? Based on the diagram, when x is 0, you go down. There's an empty hole there. That means there is no point situated there. Therefore, when x is 0, there is no y. So no solution. Understand? Okay? Now, but the moment I change the question, what is the value of the fx as x approaches 0? X approaches 0 means we're going this way, going this way. So according to the graph, we're sliding down towards here, sliding down towards here. And both sides will eventually meet y equals to -1, correct? But it will never be y equals to -1 when it is 0, because 0 is an empty hole there. Empty hole means no point is there. No point. You cannot step on it. It's like a black hole, alright? So you can't find the answer there. So you can only go to the side and see what is the answer. So both very near to -1. So the answer is -1. This is the concept of limit. Okay? So it actually answers the number line question also. When you have A and B, right? And then you have something like this. So your x will be in between A and B, but never A and B. It's in between A and B. So no value when it is at open end. Okay? Then what about the value of fx when x approaches 2? X approaches 2 is here. Okay, so you go near to 2 from the left, from the right. So according to the graph, you slide towards the 2. This one you slide down, so the x towards the 2. No, all will meet here. And this is a solid point. It exists. you can actually substitute directly. But no need, what? It say based on the graph. When the question say based on the graph, find your answer from the graph. Don't go by calculation. No extra marks for you, okay? In fact, no marks. Even you get the correct answer. Okay? So, especially the linear law question. The linear law question asks you to draw the linear graph, and then from the graph, you need to find the value of your unknown. You cannot use calculation, substitute into the formula and calculate. No. Actually, they want you to obtain it from the graph. Okay? So this one, the answer will be 3. Get the idea? Okay, any question? I erase this. Okay? So as x approaches 0, fx is negative 1. As x approaches 1, what is the y value? What is the value of fx as x approaches 1? Can you tell me? 你真嘞？嘞，不可以嘞。是啦，水hình啊，你们不要找我吃。Yeah. Okay. So what is the value of fx when x approaches 1? Yes, it's 0. Because your y is 0. Okay? So, yeah. So as x approaches 2, your fx is 3. That's it. Okay? So, limit, you can find the answer. Whether it is a solid point or an open end. But without the word limit, you just substitute directly, no solution for x equals to 0. Okay? Now, what has it got to do with our differentiation? Okay, first of all, we have to understand why gradient is needed in this topic, yeah? Now, what is gradient? Gradient is when you have a straight line, you want to find the degree of how steep the line is, right? Or the slope. We call it slope. So we will take any 2 points on a straight line, y2 minus y1 over x2 minus x1. Agree? Correct? Okay. So it involves 2 points. You must have 2 points. You see, if straight line can find gradient, mathematicians feel that curve can also find gradient. But it's very crazy because it says that find the gradient of a curve at 1 point. How do you find when you have only 1 point? Isn't it? Differentiation will come in. It is the process of determining the gradient function or the gradient of the tangent of a curve at 1 point. Why gradient function? Why gradient of the tangent? They sound different or they sound alike? Are they the same thing? Actually, they are the same thing. Now, let me just tell you this. If your curve is like cubic curve, okay, like cubic curve. So you have y equals to something like x cubed plus maybe 2x plus 5. So I want to find the gradient of tangent here. Gradient of tangent. Tangent means a straight line that touch the curve at only 1 point. That is gradient of tangent. That means it is sort of like, yeah, at one specific point here, x1, y1. I want to find the gradient of the tangent, which is the gradient of the curve at this point. So gradient of tangent at a point means the gradient of a curve. Without the word tangent also can. Okay, without the word tangent also can, because tangent touch the curve at 1 point. So I want to find the gradient of the gradient of the curve at 1 point. So gradient of the curve at point A is the same meaning as we say gradient of tangent at A. So when I say tangent, understood, only one point of the curve. Okay, then what about gradient function? What about gradient function? Because sometimes when we find the gradient is actually dy dx, it's a differentiation. The gradient of tangent is differentiation. So when I differentiate this, I may not get a value. Unlike this one, y equals to 2x plus 5. The gradient is 2. When I dy dx, I get the 2. So I have the gradient value. But for this one, the gradient is not a specific function, a specific value. It is a function. Okay, it will be like 3x squared plus 2 plus 2. So it is not a specific value, it's a function. That's why they call it gradient function. So whether we use the word gradient function, gradient of the tangent of the curve, or the gradient of a curve at one point, three of them mean the same thing. That is differentiation, dy dx. Never mind, you don't understand this one, because not yet. I just want to introduce the idea. The idea of differentiation is because we want to overcome the craziness of the mathematician to find the gradient of the curve at one point, when finding gradient actually need 2 points. So differentiation comes in. So differentiation equals to gradient of the tangent. So you remember this one. This is a very important concept. It will also become our first application of differentiation. Are you all okay? Can? Again, what has it got to do with the concept of limit? You look at this curve, and if I want to find the gradient at this point, because at this point my gradient of tangent like this, at this point my tangent will be like this. Can you see that? The line is so different. So their gradient also different, isn't it? Their gradient also different. So in this case, when you have different gradient along the curve, then you dy dx, you have a gradient function. The gradient function is a function to help you to find the gradient value when you substitute the corresponding x value. Understand? So now particularly I want A, point A. But how do I find? If I draw a straight line, okay, now the straight line in our naked eyes, we feel that that is the tangent. But do you know that if I enlarge this part, is actually passing through 2 points. The one that I just drawn, is actually, it looks like the tangent, right? But if you really open it, enlarge it, it touches 2 points. So the sketching is not accurate. So you cannot draw the line and then use any 2 points on this straight line to find the gradient and claim that that is the gradient of the curve at point A. Cannot, because that one is not the accurate answer. So mathematicians want it to be accurate, not estimate. You can estimate like this, but I want accurate answer. How? So we still use this. All right, no choice. We use this. So isn't it, if I want to find the gradient, I would take this is xy. This one, isn't it very near to my original xy? Originally, my A is 3, 5, correct? And then this one, the A, the near point, I call it A prime. Okay, it is, sorry, this is not 3, 5. This is 5, 3. 5, 3. But then this one is 5.555 and 3.308. So it's very small, very near, isn't it? So how do I find the gradient? I would take y2 minus y1 over x2 minus x1, correct? But this is still 2 points. So this gradient here is not accurate. So I will try to, fine tune it, get something nearer. Okay, still it passes 2 points. So it will be y, a new y over new x. But your x is getting smaller and smaller. So I take another 2 points, even nearer, 2 points. So I will have the small y over the small x. But not enough. We want it to be as close as possible. But I cannot put a, because if my a prime is a, so you have 3 minus 3 over 5 minus 5. So it's impossible. right? It's impossible. This is where the idea of limit comes in. Okay, so let me just use, because it's so near, we use the delta x and delta y. This one looks like a duckling, okay, called delta. Okay, now delta, we have delta that goes like this, and we also have delta that goes like this. This one is changes in x. This one is small changes in x. Okay, that is the difference between the symbol. See, math people are so lazy. Okay, so lazy. We don't want to write the word small changes or changes. We use the symbol to differentiate. Okay, so this is the fun part. Okay, you can be lazy in mathematics. So with that, if I want to find the gradient, I will take del y by del x. Okay, del y by del x. Therefore, the gradient of tangent, which is specifically, it is dy by dx, dy by dx, but I need to use the del y del x to approximate, find the approximate value. So if you take y plus del y minus y over x plus del x minus x, is like y2 minus y1 over x2 minus x1, definitely you will get this. So your dy by dx is approximately equivalent to del y by del x. Are you okay with this? Just now, this is the first application. Later you will see this. This one is the last application, number 4. We will use this later. Okay? We'll use it later. But actually, they all derive from our first principle. Now, since I need to find this, yet, because this is only approximate, when are they equals? They will only be equal when we set our del x approaches 0. As your del x getting nearer and nearer, isn't it? It is as though as it is coming back to a itself. That is the reason the concept of limit is introduced here. Okay, even though my del x is already very small, that is 0.3, consider small, but we want it as small as possible, as small as 0.000000001, almost 0. That is the reason we put this one in. Okay, this is called the first principle. This is called the first principle, where we use differentiation to find the gradient of the curve at one point. Okay, now how do we do? Let's look at the example. Okay, now of course you can use the formula. The formula in the textbook given is, some people they like to use the formula directly. For me, I prefer to use this one because I understand. Recently I just understand the formula, right? But never mind, later I will show you. So let's say y equals to 3x minus 2. We already know the gradient of this graph. The gradient equals to 3. Okay, the gradient equals to 3. But I want to use the concept of differentiation. Okay, what happened? Okay, I want to use the concept of differentiation to prove my case. Okay, how? Now, if you use the formula dy dx, the gradient of tangent, which is dy dx. Okay, the dy dx formula is the limit when your del x approaches 0, you take the function x plus delta x minus fx, that means the original function, divided by delta x. Okay, this is the formula. Alright, now, which means you substitute this, your object is x plus delta x, so you substitute into your function. This is your fx. So you substitute into this function when your x is x plus delta x. Okay, so it will be 3x plus delta x minus 2 minus fx, so minus 3x minus 2. Are you okay with this? Over delta x. Oh, don't forget the limit notation. Can? and therefore you open up the bracket, 3x plus 3 delta x minus 2 minus 3x plus 2 over delta x. Can you see that? The 3x minus 3x. Negative 2 plus 2. Left with 3 delta x. And delta x and the delta x at the bottom can be simplified. Therefore, before you substitute delta x is 0, it's already simplified. No more. The answer is 3. Okay? So you can use this formula, or if you don't want to use formula, then it will be like this. When y equals to 3x minus 2, I create my second point. My second point will be y plus delta y, and therefore my x also increase, x plus delta x minus 2. Remember just now the graph? I have my a, phi 3, and then I have my a prime, my 5 plus 0.5, that is the delta x, isn't it? So it is x plus delta x, and then y plus delta y. Okay, let this be x and y. So isn't it, you got the 2 points already? How come this one x plus delta x, y plus delta y I can put into this? Because they are in the same function. So my point here, I can substitute into the function. Whenever I see y, I replace with y plus delta y. Whenever I see x, I replace with x plus delta x. Are you okay with this? Do you understand this part? Then next, what do? I will open up the bracket here, 3x plus 3 delta x minus 2. Do you see the y here? I bring the y over. Okay, so minus the y. It's actually the same as this. Or you will see 3x minus 2 is actually the y. Okay, it's actually the y. So y plus delta y equals to y plus 3 delta x. Because 3x minus 2 is y. So let me just rewrite. There's so many ways that we can write, so I also don't know which one to show. But I better show you the minus y lah, because when we have fraction, it's easier to bring the y over rather than we use this. Then I better use that one because it's applicable for all kind of question. So del y will equals to 3x plus 3 delta x minus 2 minus the y. So minus 3x and negative 2. So isn't it this is this? Yeah. Open up the bracket. You have 3x plus 3 delta x minus 2 minus 3x plus 2. You left with 3 delta x. So delta y equals to delta x. Remember, I want to find gradient. Gradient of tangent is dy dx, so I must have del y del x first. Why? Because dy by dx approximately equals to del y by del x. So I need to write in this form. So divide by del x on both sides, you got 3. And therefore, we can find our gradient of tangent, which is dy by dx. That is when we set the limit x, del x approaches 0 of the 3. There is no del x for us to substitute. Therefore, the answer is 3. Okay? You can do like this. Or you substitute into the formula. See which one you prefer. Any question? You see, first principle is very long. It's very long. That's why later on we won't use first principle. But for the past few years, the first principle keep coming out in the trial and also in the whether they come out in SPM or not. I think so. One question. I don't remember actually. Okay, for many since my time, 1997 until now. A lot of teachers, they skip first principle until recently, 2022 onwards. The trial exam come out with first principle, then everybody start teaching first principle. I never skip because I feel the first principle is actually very important. Okay, what about if this is the function? So I will do like this. It's either you use that formula or you use this y plus delta y equals to 3. Whenever you see x, you replace with x plus delta x, and then minus x plus delta x, and then plus 4. What's next? Open up the bracket. So we have 3x squared plus 2x delta x plus delta x squared. And then minus x minus delta x plus 4. Open up the bracket, we have 3x squared plus 6x delta x plus 3 delta x squared. And then minus x minus delta x plus 4. Isn't it 3x squared? Never mind, we use that one. Bring the y over. So 3x squared plus 6x delta x plus 3 delta x squared minus x minus delta x plus 4 minus your original y. So you minus the 3x squared minus, yeah. So multiply this in, yeah. So plus x and then minus 4. So that the 3x squared minus 3x squared. The minus x here plus x cancel off. Plus 4 and minus 4 cancel off. What is left behind? 6x delta x plus 3 delta x squared and then minus delta x. What is your objective? Del y by del x. Del y over del x equals to 6x plus 3 delta x minus 1. And next, our objective is to find the differentiation dy by dx. That is when we set the limit as x approaches 0 of our 6x plus 3 delta x minus 1. So now 6x plus 3 times 0 minus 1. So the answer is 6x minus 1. That is our differentiation by first principle. Okay? You notice that from the original function to my differentiated function, this is the highest power is 2. This one, the highest power is 1. The power always reduce. From 3 terms, become 2 terms. But the number of terms not confirmed now, okay? Sometimes 3 terms left with 3 terms. Sometimes 3 terms left with 2 terms, but doesn't matter. The most important thing is the power get down. Power decrease. So D, differentiation, decrease the power, down the power. Now what if you use the formula? The formula straight away dy dx, then you have to keep writing when del x approaches 0. So you shall take the function, this one, this one, the 3x squared. So 3x plus delta x squared minus x plus delta x, and then plus 4 minus the 3x squared minus x plus 4. Don't forget, minus the whole y. So you have to put the bracket there over delta x. Okay. It's actually the same thing, just that this formula, they combine everything. Can you see that this work is actually this one? So they actually skip this. They come to this. And then at the same time, they come to this. So this one, if you open up the bracket, you are actually doing this. So you have to be careful when you do the expansion. The numerator will be very long. Okay, but actually combine everything. So we have 3x squared plus 2x delta x plus delta x squared minus x minus delta x plus 4, and then minus 3x squared plus x minus 4 over delta x. So as delta x approaches 0, we open up this bracket, 3x squared plus 6x delta x plus 3 delta x squared minus x minus delta x. The plus 4 and minus 4 can cancel off right away. Minus 3x squared plus x. So now the 3x squared and 3x squared can cancel off. Minus x and plus x can cancel off. The formula, there is still del x there. So del x approaches 0. So what is left behind now is 6x del x plus 3 del x squared minus del x. Okay, then you simplify. Haven't substitute yet, yeah? Got to factorize first. So we have 6x plus 3 delta x and then minus 1. Then we put the value in 6x, okay, minus 1. That's it. So basically the formula combine everything. The one that I write in black is I first find my second point. Then I take the new point minus the original point. This thing is the one on top. Okay? They do everything on top. And after that, I have to manually divide by x. But in the formula, they already put the delta x there. But if you understand this, then shouldn't be any problem lah. Otherwise, you have to bear the emotional disturbance to write a long numerator and be patient to simplify it. Over here is test your patience only. This one I don't have to keep writing this thing, alright, the limit of del x. I haven't used it, keep writing, but this one I only write once at the end of the dy dx. When I want to find dy dx, I found del y del x, so dy dx and del y del x will only be equivalent when you introduce the limit. So remember this, dy dx approximately equivalent to del y by del x. And they will be equal when you set the del x approaches 0. Are you okay? Alright, understand the concept? Okay, so with that, can you please do this one? Y equals to 3x cubed minus 2. Okay, are you done? How do we do the expansion of power tree? It's either you do like this, x plus delta x times x plus delta x squared. It's either you do like this, expand this and then expand slowly. Or remember the Pascal triangle? Remember Pascal triangle? Hey, have I shared with you the Pascal triangle? Right. The number here represent the coefficient of our linear expression. So 1, 1, 2. This is a plus b to the power of 1. So you have 1a plus 1b. This is a plus b, the second level, raised up to the power of 2. So you have the highest power a squared, pass down the power to b, and pass down everything to b. The coefficient 1a plus 2ab, and then plus 1b squared. Alright, so the 1 no need to write. And then 1, 1, 3 and 3. This is a plus b cubed. So the highest power a cubed pass down to b, so a squared b. The total power is 3, and then pass down again to b, so ab squared. Pass down fully to b, so b cubed. And therefore the coefficient will be 1, 3, 3, 1. So 1 plus 3 plus 3 and plus 1. That's how we expand. So put it in here. So 3, so x cubed plus 3x squared delta x plus 3x delta x squared, and then fully pass the power to delta x. So you have cube here. Okay, minus 2. Open up the bracket. We have 3x cubed plus 9 x squared delta x plus 9x delta x squared plus 3 delta x cubed minus 2. And isn't it 3x cubed minus 2 is y compared to this? So y is y here. So the delta y must be the remaining. So the delta y will equals to 9x squared delta x plus 9x delta x squared plus 3 delta x cubed. And then del y by del x equals to 9x squared plus 9x delta x plus 3 delta x squared. So now I want to find dy dx. It is my del y by del x as del x approaches 0. So equals to 9x squared plus 9x times 0. Show your substitution. Plus 3 times 0 squared. So the answer left is 9x squared only. Okay? So for this one, I won't use the formula because the expansion part is a little bit long, lengthy. But actually, it doesn't really matter. As long as you remember. If you cannot remember, you need to divide by delta x. You better memorize the formula. I won't go through the expansion one by one like this. But if you are worried that IG no issue. National syllabus got issue. They may want you to show this. But never mind. If you don't show this, you draw a Pascal triangle. You list this out for them. Then you apply. That's all. Okay? Let them go and figure it out. Right? They should know lah. They should know. If they don't know, they learn. So you don't have to expand one by one yourself. Okay? It's actually come from Pascal triangle. For IG, then you are using this a plus b raised up to the power of n, right? So you have nc0, wait a minute, a to the power of 0, b to the power of n. Or you start with n first. Let me think. Yeah. And then plus nc1, a to the power 1, b to the power of n minus 1. Okay? So as long as the total is n, so on and so forth, until ncn, a to the power n, b to the power of 0. Okay? You are writing the other way, the other direction. If you are using this formula, it will be the other direction. Are you okay? This one? Clear? Understand? Alright. There's one question in the workbook. Please try it, yeah? Please try it. You have the workbook, do you? You don't have the latest one. I have this one. This one is the last year version. Some of the questions still the same, but some of the questions is different. You can have it. Yeah. It's about the same. Some of the question different only. Okay? Right. Okay, so that's it for the first principle. But the first principle is so long, right? Most people are lazy. So long, so they identify pattern. They identify pattern. This is the pattern. Okay, but before that, let's go back to just now. Remember, when you have y equals to 3x plus 2, your dy dx equals to 3 just now, correct? And when your y equals to what? The 3x squared, what's the second one is what? The second one. 3x squared minus x plus 4. 3x squared, hey, wait a minute. Okay, the 3x squared minus x plus 4. Alamak, I got goldfish memory. What's that? 3x squared minus x plus 4. And then 3x cubed minus 2. Okay, then this one we found the dy dx to be 6x minus 1, right? And then when y equals to x cubed minus 2, so our dy dx, we found it to be 3x squared. Is it? Or in front got number? 3x squared. 3x squared. So we got 9x squared, right? There is a shortcut to it. There is a shortcut to it. The power is 1 here. The power is 2 here. The power is 3 here. After dy dx, the power bring down to the front 1 minus 1. So you have 3. Because 1 minus 1 is x to the power 0. X power 0 is 1. This one you bring down the 2 to the front, 6x. The power 2 become power 1. This one power 1, you bring 1 to the front, left with x to the power 0, which is 1. This one you bring the 3 down, multiply with the 3, 9. Power 3 become power 2. Constant will always be 0. This is the shortcut. We call it the first derivative for the for different function. So we shall use this later, yeah. So good news. First principle is just to let you know how does this come about. Once you understand the first principle, no need to use the first principle anymore unless the question asks. IG don't have this issue. SPM, I don't think they will ask lah, okay? I don't think they will ask, okay? This year, I think the question will be much easier because the learning time is so short. They have to finish the syllabus because our school start in March early this year, right? But they have to sit for the exam in November. So they have like lesser than how many? 6 months or 7 months. 7 months to cover the syllabus. So this year question will be very easy. Okay, but anyway, now the first derivative, if y equals to fx, is a curve. It may be a line, it may be a curve, doesn't matter. The dy dx will be the gradient of the line or the gradient of the curve at one point. So the concept is this: mt gradient of tangent. Gradient of tangent means the gradient of a curve at one point. So it's either I use mt equals to dy dx or mt equals to f prime x. Another way to write differentiation, the differentiation notation is f prime x. Okay. Or the operator of differentiation, the symbol to indicate, okay, let's execute the operation of differentiation, is d by dx. Where does the y go? Y is your subject lah, depends on what your y is. Okay, remember the function of the differentiation notation is actually d by dx. Okay, and mt is the gradient of tangent. We can write dy by dx or f prime x. Now, for example, when you look at the question, differentiate 3x minus 2 with respect to x. How should we write in terms of symbol? As I said, we don't like words, right? How do we represent this in terms of symbol? It will be like this. Differentiation notation is d by dx. There is no y given. That means I have to copy the whole expression itself because it is with respect to x, so d by dx. Can I change the question? Differentiate 3z minus 2 with respect to z. Then yes, it will be, because you differentiate with respect to z, so it will be d by dz onto 3z minus 2. Okay? So that's the idea of the differentiation notation. I can also say dy with respect to y. So my expression must be in terms of y lah. Okay, right? So not necessarily it has to be dy by dx. The dx at the bottom means which power of variable you want to reduce. I want to reduce the power x, so differentiate with respect to x. This one I want to reduce the power of z. It will be differentiate the power of the variable of z. Differentiate with respect to y. Understand, yeah? The differentiation operator. When the question gives y equals to 3x minus 2, then we won't say differentiate 3x minus 2 with respect to x. I would just say differentiate y with respect to x. Or the best still is dy by dx. Save your ink, save your breath. Okay? Right? And then if you are given fx equals to 3x minus 2, find the first derivative of the function f, means differentiate the fx. Okay, differentiate the fx lah with respect to x. Alright, so we will write like this. F prime x. Can we write like this? Yeah? Can we write d by dx onto fx? Well, yes, you can. Why not? But instead of writing that, the extra bracket and the d by dx, I just add the prime. I save my ink. Understand? Lazy maths people. Alright? These three things means the same thing. That is differentiation notation. Is that okay? So don't get confused. They are actually the same thing. Just like my children call me mommy, sometimes mother, right? Then I have my own name. But when I go to school, the people will call me Puan Mak or Miss Sydney. But it is still me. I have different name. So differentiation is the same. I just have different way of writing it. But they are the same thing. Okay? Right. So understand this. Then let's move on. Okay. As I said, the first principle is just too long. Is there any shortcut? This is the shortcut. The first derivative of various types of function. As I said, when we differentiate with respect to x, the power of x will be reduced. when y equals to k, whereby k is a constant, you differentiate y with respect to x is 0. Because there is no x for you to differentiate. 0. But if I really want to be serious, to fit into the definition, y equals to k basically is y equals to k times 1. K times x to the power 0. Right? So dy dx will be, I got to bring down the power of 0 to be multiplied with the k in front. So 0 times kx, 0 minus 1. So I have 0 times k x to the power of negative 1. But regardless of what you have here, 0 times anything, you get 0. Understand? So that is why you get your dy dx equals to 0. Can? So in short, there is no x for you to differentiate, therefore you got 0 when you come to constant. When you have y equals to ax to the power of n, as I said, bring down the n to the front to multiply. Copy everything. After you bring down, you copy exactly ax to the power n. Now you minus 1. So the first step, you multiply the whole term with the power. Then the second, this is multiply. Then minus 1 from the power. From the index lah, but from the power. Okay? Times terms with power. And must remember minus 1 from the power. That is differentiation, the shortcut of differentiation. Now what if my y consists of different terms in x? Now what does this mean? It could be, I can continue like this, GHX. So when I differentiate, I also can do like this. So what does that mean? I have y equals to 5x cubed minus 2x square, and then plus 7x plus 4. I got each and every term can be differentiated separately. So bring down the power, so 3 times 5, 15x squared, minus 2 times 2, 4. See, you times the term with the power, and you reduce the power by 1. This is 1, you multiply with 7, you got 7. After you reduce by 1, x to the power 0 is 1. That's it. Constant is 0, no need to write. That's it. Can you see that? Your power from power 3 become power 2. Power 2 become power 1. Power 1 become power 0. So that is differentiation. Derivative down the power. Equalize d with reduce the power. Is that okay? Easy, right? Super easy, this one? Super easy. What is this? Okay. So let's move on with something difficult. This one is easy so that you can, I think you can try the question here. Wait, let me just get, okay. Right, you look at the workbook. EPH, MS, 2025. Okay. Right. For those who take IGCSE number 1, 2, 3, no need to do. But if you want to challenge yourself, please try. You all cannot skip, must do. So you can try until find this by using first principle. Okay, this is the one I'm talking about. This one not yet. Okay, B don't do yet. The B here don't do yet. We'll do later, or maybe the whole question. You can do this because you are supposed to use the first principle to find the gradient function. Actually, this one very easy. Find the gradient value when yeah, where the gradient value is 2. The one that you found, right? Remember, the gradient of tangent you found is equals to the 2. And what is the gradient function? Then you put the point in, then you can find, yeah. But never mind, you can just leave it. Do A first, B don't do. Okay? Now, the first derivative, you can try number 7, number 8, and number 9. Now, the number 9, right, we only know this kind of derivative. But this one, when you have product, I think you need to use expansion. You expand first so that it is written in fx plus gx plus hx, so on and so forth. This one, you factorize first so that it come back, no quotient, no multiplication. This one also you factorize first. Okay, no need to use special rules, yeah, just factorize and then you differentiate yourself lah. I mean differentiate using the concept that we were using just now. Okay, yeah, I don't want to cover too many things. Let me think first. We still have time, so we can, okay, never mind, let me just show you this. What does it mean? Okay, show you this lah. Show you this. How do we derive this? Now, when you see the index form, especially the surd form is very irritating. When we want to do calculation, no surd form. So you have to change the surd form into the fractional index. So y equals to negative x to the power of 4 over 3. This is 3 root, right? Root must grow underground, so over 3. So with this, I can find my dy dx. That is, bring down the power to the front, multiply with the negative 1, so we have negative 4 over 3, x to the power of 4 over 3 minus 1. So 4 over 3 minus 1, you left with negative 4 over 3, x to the power of 1 over 3. So you can leave your final answer, negative 4 over 3 cube root of x. That's it. Okay? Right. What about this? It will be y equals to negative 2x to the power of negative 2. Because what we learned just now, when y equals to ax to the power of n, is this format only. So when our question is not in this format, try to change it back into this format. That means your index form must be x to the power of n. Your n could be positive, could be negative, but it will never in the denominator. So when you see it in the denominator, you bring it out, and then this one we can differentiate. Bring down the power to the front. If you cannot multiply straight away, you bring down first, then you copy the terms exactly, minus 1. Yes, then only you simplify. So we will have positive 4 x to the power of negative 3. Now we don't want to leave our index in negative form, so dy by dx, we adjust it, so 4 over x cubed. That's it. Is that okay? Simple? Easy, right? So remember to change this, then only we can differentiate. Change this, change this. Okay? This one, you got to expand it, because when you expand it, now I haven't differentiated, so don't put the f prime. Okay, so we expand this, I have x cubed plus 3x squared minus 5x minus 15. So now, isn't it, we can f prime x. Differentiate this, differentiate this, differentiate this, differentiate this, you got 0. Simple? Okay, you do. So this one you got to factorize first. So it tests your skill of factorization. X cubed minus x, how can we factorize? If we cannot factorize, then we separate it. It will be x cubed over x minus x over x plus 4 over x. It's not factorized. It's like separated. It's separated. No point, there's no way I can factorize it because this is x cubed and x and then this is 1. No way I can, I learn x cubed, factorization of x cubed, cannot. This one, yes. This one, it will be x minus 2 and x plus 1 over x minus 2. Okay, why I write x minus 2 first? Because I know can be simplified. So x minus 2 must be able to simplify, otherwise they won't ask. Okay, so you left with x plus 1, so f prime x will be the x plus 1. So power 1 bring down, become just 1. That's it. Because it differentiate, the 1 is 0. Is that okay? Easy? Then do now. Do, let me see. Do number 8a first. Do 8a and b. Yeah, sorry, I missed the message. Who sent me message? Wouldn't it be a little inaccurate for the gradient of tangent? Chen Yu, which one you asked actually? Didn't see your question just now, but is it, your doubt, is it clear already? Yeah, clear already, okay. Demo, which one? dy dx del y del x. Okay, just now I want to answer this question. The differentiation, first principle question, yeah. You already found del y by del x equals to a very long terms, yeah. So when do we write this limit? When we write dy by dx. The moment you write dy dx, del y by del x is an approximate value. It's still approximate gradient. The exact gradient is dy by dx. Okay, so this is like a cursive d, so it's like about, cursive, approximate, accurate one, it will be a dy dx. So dy dx is when you set the limit of del x approaches 0 for your del y by del x. So you write it with the title dy by dx. Okay, so here, oops, too thick already. Must you write? Yes. Okay, you have to write because our final answer is to find dy dx. So dy dx must be written. Yj is no, jy. Okay, Jia Ying. Jia Ying, just now you asked which question that you want me to do the demo first. Ah, understand already. Okay. Alright, done. Can we check? Check. This one. So you differentiate this, so it will be 4x plus 3. That's it. Is that your answer? Okay. This one. Now, this one maybe we have to do like this. Everything must be in the differentiated form. Then only we start to differentiate. Okay, now we start to differentiate. It will be 2x. Bring down the power -1 in front. You have -1 times 2, -2. X to the power -1 minus 1, -2. And always rewrite with no negative index. So it will be x squared like this. Okay, try not to leave your answer like this. We don't like negative anyway, unless it's cannot avoid, then like the sign minus has to be there. But the power negative, if can, we write in terms of positive. Okay? Right, easy? Super easy. So far what we have learned, we have covered the concept of limit and the first principle. Try to do all the question until question 9. Okay, number 1 until question 9 must try, except the 6b, don't try yet. Okay, and then those take IG, number 1, 2, 3 no need to do, okay, because it's not in your syllabus. But if you want to try, welcome. Okay, because mathematics basically is a gymnastic exercise for your brain cell. Yeah, you're welcome to try. So I will see you. We still have one more class next week, correct? Yeah. Alright, see you next week. Okay, good night everyone. Okay, thank you. Stop recording. Stop recording.